Clean holes and panels on bent surfaces, hard surface and sub-D. Today I'll show you how to make clean, artifact-free holes and panels on bent surfaces. You'll learn how to improve geometry for both hard surface and subdivision workflows. I'm not covering Booleans, there are plenty of tutorials for those. Here we'll do it by hand, so you build instincts that level up every model. Mastering topology is a long game, so we'll focus on simple subjects rather than full, complex assets. Create a plane and add a few subdivisions. Add simple deform. Set it to bend to curve it. You can use a cylinder or any other bent surface. Duplicate the object so you have a clean backup for later. Cutting a round opening. Add a center cut, then use the knife tool to draw the opening. Delete half the mesh and add a mirror modifier for mirrored topology. Delete the inner faces of the hole, then apply mirror when you're happy. Select the hole loop and run Loop Tools, Circle to round it. Add a subdivision surface modifier and insert support loops near the outer borders to prevent corners from becoming too round. Optional densifying. If needed, add more topology by hand, at least one subdivision per edge of the hole, then connect those edges cleanly into the surrounding mesh. For speed, delete half again and reuse mirror. Even without subdivision, add a tight support loop if the object will be close to camera. It helps reflections and later steps. Preparing a smooth reference. On the duplicate copy, select faces and subdivide. If you already applied bend on that copy, add a subdivision surface modifier to smooth it further. If you simply refill the hole now, it often won't be a perfect circle. Bending usually turns circles into ellipses. So we fix the shape after deformation. Shrink wrap to a reference. Add a shrink wrap modifier on the detailed mesh to conform it to the smooth, bent copy. In project mode, projection uses the modified object's XYZ axes. Set the proper axis checkboxes or rotate the modified object to align. Choose positive or negative direction, add a small offset, and tweak position and scale if needed. Apply shrink wrap, then run Loop Tools, Circle again to make the hole perfectly round on the curved surface. Fill the face, extrude along normals, and rotate and align to match the surface flow. Never start extruding faces without support loops. You can delete them later, but they stabilize shading while you work. Quick pattern selection. Use Select, Checker Deselect to pattern select faces. Press I for Inset. No sub-D path, hard surface. If you're not using subdivision, extrude now. Select edge rings, Alt-click, use the free Zolupunt tool to extend loops or select by hand, then bevel the edges to set width and highlights. Bevel tip. Bevel with an odd number of segments, it's easier to remove the middle line later while keeping the shape. Cleanup and curvature. Do a targeted n-gon cleanup. You don't need to resolve every n-gon, but for clean shading and reflections, extend a few loops to the border edges.
Work on one half with mirror to go faster. Use Loop Tool's Space to even spacing. If the mesh has no modifiers, make a tessellated copy and shrink wrap the detailed mesh onto it to preserve curvature. If you don't want modifiers to affect everything, plan to limit them with vertex groups. Subdivision path. Sub-D needs careful support. At the inset border, add at least one, ideally two, vertical support loops, or the face will warp when you extrude. Add horizontal loops as needed. Fast trick. Create one center loop, then Ctrl-B to split it into two equidistant edges. Clean up any unwanted faces or edges before moving on. Mark edge seams around them. Lattice deformations, underused but powerful. A lattice can deform a mesh or part of it without changing topology. Add a lattice, scale it to enclose the mesh. Important, don't apply the lattice's object mode scale after fitting. And set U, V, and W resolution for control. Add a lattice modifier to your mesh and point it to the lattice object. Optionally, Ctrl-P, lattice deform, to parent so they move together. Stack order matters. Keep lattice above topology changing mods like subdivision or solidify. Paneling with knife project. Start with a plane, no subdivisions. Use the knife tool to draw panel borders. Select those edges, optionally mark seams, then Ctrl-B, bevel to form panel gaps. Build a cutter stencil. Create a second plane, cut it several times, and make it slightly larger than the object. Select all faces and press X, faces only, so it becomes edges and vertices only. Orthographic view. Use 1, 3, 7 for front, right, top. Control for the opposite views. 5 toggles perspective or ortho. 0 goes to the camera. In object mode, select the stencil objects first. Shift-select the target mesh, target, last so it's active. Enter edit mode on the target, press 3, face select, then A to select all faces. Mesh, knife project. Blender projects the stencil and cuts clean panel lines from the current view. From here, you can refine with modifiers as needed. Final shading cleanup, data transfer. Keep 2 versions, the detailed mesh, cuts and panels, and a clean, evenly subdivided reference. On the detailed mesh, add data transfer, source, the clean reference. Face corner data to custom normals, mapping, nearest face interpolated, start mix 1.0, then lower if you want to retain some original highlights. In object data, normals, enable auto smooth, try 60 to 80 degrees for hard surface. Optionally limit with a vertex group. Vertex groups refresher. Make a selection, plus, to create a group. Rename, Assign with weight equals 1.0 for full influence. Use weights less than 1.0 to feather effects for blending. Stack order tip. Place data transfer at the end of the stack after subdivision or solidify, so transferred normals aren't overwritten. If you also use weighted normals, decide what should win. Keep data transfer at last if you want its shading to prevail. My settings here: face corner data with nearest face interpolated mapping.